Welcome again to one of another videos of AI Maths Buddy. In this series, we discuss how toppers think. We don't give solutions to you. We try to understand if there is a problem that is difficult that they are doing, how will they approach it? What are the things that they will do? So, so let me take a question of sets, and this will be IIT mains question. So just pause this video and try to solve it on your own. In case you're not able to solve it, then you see this video. So what this question is saying is that there are two finite sets, A and B, each having elements. So A is having m elements and B is having n elements. The total number of subsets of A is 112 more than the total number of subsets of B. And he is asking what is the value of m into n. Now there are multiple concepts here. First, it is testing your permutation and combination. Second, it is obviously testing your sets concepts. Then it is also testing factorization, whether you can solve quadratic or factorization polynomial or not. So there are three things that is getting tested. So let's assume that we are not able to solve it, and we click on understand the concept. I repeat once again that we are not here to give you the solution. We are here to think how a topper will approach this problem if he gets stuck. So the first helping question is, if a finite set A has m elements, what is the total number of subsets of A? Now, this is actually not a set question. This is a permutation and combination question. If you're able to solve it, very good. That means you understand PNC very well. If you're not able to solve it, it means that you should practice PNC questions. There is nowhere else where you can understand which concept is weak other than on this website. So if you are getting it wrong, just open up your questions, or you can practice through our website also and practice at least 10 questions of permutation and combination and try to think deeply into them. Now, what is the answer to this question? So say if set A is A, so let's say I know the answer to this question, 2 raised to the power m, but let's say I select m factorial. Now this is incorrect. What I can do is I can do two things. Either I can go deeper into this permutation and combination concept here itself, or I'll just ask the answer. But let's try to understand this permutation and combination and go deeper into this here itself. So he is now helping us how to think in that permutation and combination thing. So the first helping question is, when constructing a subset from a set, how many possible choices do we have for each individual element? So for each individual element, how many possible choices we have? It can be either included or excluded, right? So how many subsets does the empty set have? So if there is a no element, how many subsets will this have if there is a no element? I think this should be 1 because there is no subset. Now let A is equal to alpha be a set with, let A is equal to A be a set with one element. What are the possible subsets of A? So he is trying to make you understand how do you calculate that answer, 2 raised to the power m or 2 raised to the minus 1. So the possible subsets of A will be one null set, another will be A. And now let's see how it is building up this. It's very, very good if you are understanding it, if you are following up. So he first make you understood what is null set. Then he take one element and showed you number of subsets of that. Now he has taken two elements, A and B, and asking you to calculate the subsets of this. So one will be null, one will be A, one will be B, and other will be AB. So there will be 4 subsets. So when constructing a subset from a given set, how many choices do we have for each element? Either we include it or exclude it. Include, exclude, or half include is not an option. So we have again come back to the same thing. this is helping question 2. Now you know that if a finite set B has n elements, what is the total number of sets of B? See again, if we do it wrong, n factorial, we can now here understood it quite well. We can just see the answer also. So the answer is 2 raised to the power n, right? Now he's saying that given now this is third helping question. So in the first two helping question, we have mastered the concept of permutation and combination. If you are a student who just sees the solution and is not going back to the permutation and combination chapter and solving at least 8 to 10 questions right now, then you're not doing justice to this question. You need to do like that. That's how toppers do. Now the next helping question is, given the total number of subsets is 112 more than total number of subsets, which of the following equation is correct? So obviously this will be 2 raised to the power m minus 2 raised to the power n is equal to 112. This is fairly simple. Now we have to solve for this because we have to find the value of m and n so that we can get m into n. Now 2 raised to the minus n, 2 raised to the minus n is equal to 112. How should we calculate it? Now, again, this is a question for quadratic or factorization or polynomial, whichever chapter you put in. If you're able to do it, very good. If you're not able to do it, then you should again open the book and try to do some questions on factorization, on factoring the polynomial. So here it is saying that I have taken 2 raised to n common, and this will be 2 raised to minus n minus 1. So what will happen is this is even, this is odd. And then you can see how we can break 112 into that. See, again, I get it wrong, suppose. You can see the answer here. So what happens is that this 2 raised to the power n is equal to, is actually 2 raised to the power 4, which is 16. And then you put m is equal to 7 and you get this answer. Now, obviously, we have got the value of m is equal to 7 and is equal to 4. We can simply find the value of m into n, which is 28. So you have seen that in this question, many concepts got tested. What was important is that we came to know that our permutation and combination concept is weak, or our factoring polynomial is weak, or our understanding of sets is weak. Whatever is weak, solve a few more questions, read the theory again, and that's how you do it.